Hey guys, this video will act as a walkthrough for assignment 1, in which I'll start with the blank A1 files and take them to a 10 out of 10 submission. Before we jump into it, however, I'd like to give a brief description of why I'm making this video and who I think will benefit from it the most. So in interviews, I tend to get a few students per assignment who had a harder time than most and either didn't know how to start certain sections of the assignment or toyed around with some sections but didn't end up finishing them. Another common thing I find is that some students are generally curious as to if there's a better way to solve certain problems in the assignment. So I'm going to attempt to address both groups in this video, so you'll definitely get some value if you found yourself in either camp for assignment 1. My goals for the video then become, I'm going to show you how to start an assignment when you're not sure how to start. I want to demonstrate proper documentation and how I recommend that you code. And finally, I just want to show you the assignment through a tutor's eyes. So to show you how we're going to be working throughout this video solution, I've got on my desktop here my assignment 1 folder. It's got all the files we're going to be needing for the assignment. So I've got a1.py, the support code as well, and then I've also downloaded the test files as well, so we can run the test cases alongside our assignment as we're going, which is generally a really good thing to do. So if I show you the different idle windows we'll be having open throughout this video, I've got my a1.py here on the left. That's the thing we're going to be writing to the most. Up the top right hand of the screen, we're going to have the sample tests. We don't have to read this at all, but we're just going to be running this, and that will generate down here in the bottom right this big blue text telling me like how much we're passing currently. And you can see we're not doing very well. We haven't. I'm just running this to show you that nothing's working right now, but we're going to be changing that throughout the course of this video. So yeah. All right. So assignment 1. Or a1.py rather, when you open this for the first time, it might be a little bit intimidating, you might be wondering where to start. To figure out how the hell we are going to start, I've also brought up the task sheet here on the right hand side. So reading through this, there's a little bit of an intro as to what Caesar ciphers are in the first place. And there's some example output of how the whole program should run finally after you finished it. And then if we scroll down, there's a section called Getting Started. This describes, how the individual files are meant to be used, and then just after that, it also shows us what functions we're required to implement for the assignment. Those being encrypt, decrypt, find encryption offsets, and main. So, even if we don't know specifically how to write the bodies of encrypt or decrypt or find encryption offsets, we at least know that we're going to be needing the function somewhere within a1.py. So we can just go ahead, and our first step can actually just be making those function definitions and leaving the bodies as pass for now, right? So I've copied and pasted what I need to do for those 3 functions, and you can see I've put pass in each of them, which just means we haven't implemented this yet. Return nothing. So now that we've got the function definitions written, the next step is always going to be docstrings. Docstrings, it breaks our tutors' hearts when we open up a new assignment to mark, and all the functions there are no docstrings on any of them. I should probably show this as well. This assignment, the marks for it were such that like half the marks for the whole assignment were, documentation and programming style. So if you weren't spending like 50% of your time then on making sure that your assignment looked nice and had proper documentation, you probably weren't spending your time appropriately there. Okay, so docstrings. This is how a docstring looks. First of all, I want to give a brief description of how the function is going to work. So encrypt, we want to Okay, so that's the brief description of what the function does, and then you have 2 more sections. You have parameters and returns. So parameters. First of all, you want to give the name of the parameter you're describing, so text in this case. What type is it? It's a string. Then you've got offset. Offset is an integer. And then finally, we have the return section. Now, you don't need to describe the variable name that you're returning in this case, because, to the calling code, it won't have a name, right? It will only have a type. So what is the type of what we're returning? It's a string, right? And it is simply the encrypted text. Cool. So that's our docstring finished. I'm going to go ahead and put these on all three, or I guess all four functions here, and then I'll fast forward up till I'm going to talk to you next. So now let's implement our encrypt function. So there are two ways you could do this. The first and I guess most common way was that students would define a variable, or at least they should have defined a variable, a global variable at the top here called alphabet. Made this a big string containing, you know, all the alphabetical characters in order, and then they would use methods like alphabet.find and given a certain character like this to get the index of A inside this big string, and then, you know, they do some math with that to add offsets and stuff like that. Or they could have used, instead of find, index as well. Sorry, index. But we're not going to be doing this method. We're actually going to be using the two functions odd and char inside this solution. So odd, you give it a character, say for example A, and we don't care what number it gives back exactly, but it gives back a number which corresponds to the ASCII representation of A. Yeah, and char is sort of the reverse, right? The reverse rather. So if I use char on the odd of A, then right, odd will convert A to a number which is the ASCII representation, and then char takes that number and converts it back to the corresponding letter again. So this whole thing will just give me back A again, because I guess they are inverse functions of each other. So how do we actually write encrypt? If we are returning the encrypted text, quite frequently what you see with these sorts of functions is that we want to be building up a string as we go along. So we can do that at the very beginning. Result, which is what we're going to be returning in the end, is just equal to the empty string by default, or immediately, right? So we've created result, and eventually we want to return at the end, so we can say return result. Yeah. And in the middle of these two sections, you know, we're going to be building up result. So how we do that? Well, we want to loop through each of the characters in the supplied text and, you know, add the offset to it and get the corresponding encrypted character, then add that to result. So let me type out what I just said. Okay, so this first section is relatively easy, right? If you guys know how to loop through each of the characters, we're going to use a for loop in this case, just because it's going to simplify the logic a little bit. I'm going to say for letter in text. Easy enough. And I don't need this comment right now. You can imagine this sort of thing as just scaffolding. It's just sort of simplifying my thoughts at the time. Yeah, because it's clear enough from this line what the intent is there. Okay, so this is a little bit more complex. I want to convert the letter to the corresponding encrypted character. There are a few cases here, right? Because this is going to look different depending on if the letter's uppercase, if the letter's lowercase, or if the letter's anything else. So let's split it up into those three sections. So first of all, I want to say if letter dot is upper, I'll do something. Then if letter dot is lower, I want to do something else. And then finally, in all other cases, and I guess this case is probably the easiest one to implement and think about, this handles if it's a space, if it's a hyphen, if it's an apostrophe, things like that. We just want to add the letter as it is to the result, right? So I'm just going to say result, append letter as it is. Okay, and this is done. So now we only need to deal with the cases in which the letter is uppercase and lowercase. So I told a lie. I said that I'd be using odd and char within this function. Now, if you look at the timestamps in this video, you would see that there's some sort of hour gap in between, like the last section and this one. And that's because it's just a little bit difficult to explain, for me at least, putting the range of odd where we want it to be. So we're going to default back to that other implementation I talked about where I'm defining a global variable up here called alphabet. Sure, and I know that I can just import string and make this ASCII lowercase, but I'm just showing you how you might go about this if you didn't know how to do that. So I've defined this variable up here, and then I want to do a few things in this is uppercase. First of all, I'm going to make a new variable called index, and index is going to be the index of this letter inside this alphabet. Okay, so I can say alphabet.find letter. And this is currently not going to work. Letter, because this is the case in which letter is uppercase, and alphabet is an alphabet of lowercase letters, we're not going to be able to find the proper index here, so I just have to say letter.lower, which will convert letter to lowercase first before we try to find that. Okay, cool. And then I can say encrypted index is equal to index plus offset, right? And then I want to modulo this whole thing by 26 just to bring that into the range that we want. And then finally I can say, so this is my uppercase case done, and we can copy and paste something very similar for the lowercase case. God, I love saying that. Except we don't have to do this dot lower and dot upper thing just because alphabet is already lowercase. Okay, something that I saw when I was looking back at this is that I put an if here, and that's incorrect. I actually want an elif. The reason being is because, say for example, letter was uppercase, so say for example I had an A here for text. You know, I'd go through these three different sections. I'd evaluate this upper section, right, and I'd eventually add the encrypted version of A, but I would also do this a second time as well, just because, right, this else is now attached only to this if, as opposed to all three. So now my encrypt function's actually done. I can come across to decrypt and write it in one line like this very simply, just because, you know, everywhere that I wanted to add the offset inside encrypt, I just want to minus it in this one. This sort of brings me to something that I saw quite frequently within student submissions, which was that the decrypt function was this instead. This is exactly what we just talked about then. The issue with this is that you're really just copying yourself, and it's not as concise, and what happens if, for example, you get something wrong here, it's now harder to debug, as opposed to, you know, having this as a simple one-liner, and then you just have to focus on getting encrypt working, and you have both encrypt and decrypt working just fine. So let's actually see if this is working or not. And yeah, encrypt and decrypt seem to be working okay. Alright, so the next section, now that we've done encrypt and decrypt, is find encryption offsets. And this was the most difficult part of the assignment for a lot of people. I'm going to try and walk you through how you might think about this if you weren't sure about where to start. So the way that I like to think about this is, how would you solve this issue if you were provided with it instead of a computer, right? So say I give you a big string of encrypted text. How would you go about finding the possible offsets it was used, or that could be used to decrypt that text? Something that you might come up with in this case is, you might just pick one offset, you know, and go through and decrypt every single letter in the string, and then you just look to see if the whole sentence made sense. And if it did, you would add that offset, you know, to the list of possible offsets you were looking at. So let's go ahead and write that down. That's what we want to get in the habit of. So I want to okay, so after we've decrypted the encrypted text for a specific offset, we want to check that each individual word is English using that function in the support code, right? So we need to have some sort of way that we're going to split this big string up into individual words. And we're going to do that with the split method, which I'll showcase next. But what I'm trying to do now, again, is just scaffolding, you know. So next, and then after we've got the individual words in a list or whatever, and then okay, and then finally we just return those offsets. Okay, so this is sort of the structure for this function. And now that we have like the scaffolding there, it's really easy just to fill it out, as opposed to, you know, being stuck and worrying as to what the next step is, and ultimately, you know, not making very much progress. So let's work through this quickly now. If we want to be returning offsets eventually, and it is going to be in a tuple, you could do one of two things here. You could, first of all, you could make a variable called offsets, and you could either make it a tuple or a list, which is what I'm going to do in this case, because I guess tuples being immutable and all, it makes just more sense to me, at least, to be appending to a single list and then eventually converting that to a tuple. We're initializing offsets to be empty by default, and we want to loop through all possible offsets from 1 to 25. Now that's relatively easy. We can just say, and actually let's go to 26 here, because, you know, we want it to be 1 and including 25. So for offset and range 1 to 26, we want to decrypt the encrypted text, right? So I can say decrypted. Actually, I can do these two sections here, this comment and this comment in one line, decrypt the encrypted text, and then split that up into individual words, right? So I can say words is equal to, and then we want to split this up. And if I don't supply any arguments to split, it will just split on the spaces, which means it's going to give me back a list of words. Okay, cool. So that's these two sections done. And now if I want to loop through all the words, I can say for word in words, right? And that's going to now set word to each new word inside this list. Okay, so checking that all of them are English, you can do this a few ways. I'm going to do it with something called flagging, or flagging. Yeah, I think it's called a flag, what I'm essentially going to be using here. So I'm going to set, for a specific offset, I'm going to set a flag is valid to be true by default. And then if I encounter a word in words which is not English, I'm going to set is valid to false. And then we can check the value of is valid afterwards and see what it is. Okay, so check that all the words are English. I'm going to use the support function now, is word English. So let's copy that across. If not is word English, and then I give it the word that I want to check. Also remember that I need to make this lowercase because the dictionary can only handle lowercase words. And you would have to read through the support code docstring to figure that out. So if not is word English, right? We want to flip the value of that flag. We want to set is valid to be false. Okay, and then at this point here, where my cursor is right now, you can imagine that we've gone through the entire list of words and we've checked if each one of them is valid or not, right? So here we can just do a simple check. If is valid, then I want to say offsets.append the specific offset. Okay, and then finally, we want to return offsets as a tuple, so return tuple offsets. And that's our find encryption offsets function done, relatively simply. Now I can delete lots of this scaffolding because it's making it a little bit hard to read. So, you know, loop through all the offsets. We don't need this comment here. This is telling me what, well, sorry, it's actually clear from the code as to what this line is doing. Same here. Yeah, I mean, this comment right here could probably go above this section. However, again, look, to me at least, it's clear enough from the code, so I don't particularly need this. So let's go like this and make this nice and spaced. Okay, so that looks a lot better to me. The only place that really deserves a comment, I guess, is this section where you're checking if all the words are English. So yeah, maybe a nice inline comment here would be good. Just something like that. Okay, and let's now check that this is working properly. Okay, and it's saying that find encryption offsets is now working, which is great. We'll come back to this function in a little while when we're implementing the extension task, but for now, that's all good. So the next section we're up to is actually our main function. And if finding encryption offsets was the most difficult part, main is the most boring part of this assignment. What I mean by that is that I'm going to be copying across from the task sheet a lot, essentially. So I'm going to open the task sheet up here on my right-hand side, and then we'll go through what main's meant to look like. So here in example output, it shows you what the program's meant to look like when it runs, and keep in mind that this is one continuous run of the program. It's just looping over and over for different responses every single time. So we can see here that when the program's opened for the very first time, it says, "Welcome to the simple encryption tool," right? And then there's a new line, and then there's this "please choose an option" part, which seems to be repeated quite a lot, right? So, okay, the first thing we want to do then inside our main function is a print statement which says "Welcome to the simple encryption tool." Okay, easy enough. To deal with this new line, I note that, or you can note rather, that every single time that like one logical execution of this program finishes, there's a new line to start off with there. Now, how we can address that, I saw a lot of this inside students' code where they'd put that new line at the end of the initial print, right? And then they'd have, you know, the please blah 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 blah. The issue with this is that after your second run, you're not going to have a new line in between blocks like this new line right here. And I mean, the simple fix to this is that instead of having the new line inside the initial welcome message, we can put it inside this big prompt here. So I'm actually going to separate this out into a separate function. I'm going to call that function prompt. And what prompt will do is it will just return the character that the user has entered, which I will save inside a variable called response. So let's write prompt. There's going to be a lot of typing throughout this main function, so I'll probably fast forward a lot of this and only talk for the parts which I feel like need it. Okay, see you shortly. Okay, so there are a few ways you can do this. You can use a multi-line string, and what I mean by that is it's the same sort of thing as you've seen with docstrings, this triple quotes, and then you wouldn't have to use this like explicit ending a string here and explicit putting in the new lines like I'm going to have to do as well. It's just, for me at least, this is a matter of personal preference. I find it easier to see when it's just the individual strings instead of and like joining them up with this / character as opposed to the multi-line comments. So I also forgot to put the new lines at the end of each one of these, and that would have just made it, you know, one long string of text. Okay, so now I've actually finished my prompt function. I want to use it inside our main like this. So after we print the simple encryption tool, you know, that welcome message, we actually want to be doing this next section essentially until the user enters a queue, right? And until they want to quit out. So we can surround this next section in a while true. The first thing we want to do is prompt them for their response. And before, you know how I was talking about putting that new line at the start of our prompt, well, I actually forgot to put that in. Let's do that right here. Okay, so while true, we get the response. Then we want to check to see what they actually entered in, you know. So let's separate this into the individual cases now. Okay, now we can fill in these individual sections. So what's the easiest one to fill out? Probably Q, our exit condition. If they enter in a Q, well, what do we say? We just say bye. Print out bye, and then we can exit. So print bye, and then to actually exit this while loop, I'm going to use a break statement there. Okay. And then I guess I'll stop talking for a little bit. I'll be copying and pasting some code, not some code, I guess some text from the task sheet to try and make it look look like this example outputs here. Okay, for the automatic case, when the user selects A or inputs A, I guess, I'm actually going to separate this out into its own individual function, just because it gets a little bit longer than the encrypt and decrypt cases, and it would be nicer. It may be a lot more concise if I ended up separating this out. So I'm going to do that up here. I'm going to make a function called So here's the section where I guess the automatic case gets a little bit more complex. You have multiple things that you want to do depending on what the return value is from fine encryption offsets here. So first of all, I guess what I want to do is get that value from fine encryption offsets. So I'm going to say a new variable possible offsets is equal to fine encryption offsets, and instead of encrypted text, it's just going to be text in this case. Okay, so the different cases occur here. You know, it's different if there's multiple encryption offsets, if there's no valid encryption offsets, or if there's only one valid encryption offset. So in all three of them, all three cases there, the difference, I guess, is the length of possible offsets. You know, how many things are there in that tuple? So what we can do now is split this out into the individual cases. So encryption offset, and then I'll actually have to supply it the valid offset. So we know, right, if possible offsets only contains one integer, right, then we can access that like this. And that'll be fine. That'll give the valid offset there. And then I also want to print out, well, what my decrypted message is, because I mean, if it's only valid for one specific offset, it would be nice if I could print out what the original text was. Okay, and that's the case in which there's only one of them. Final case is if there's multiple possible encryption offsets, and we can just handle that with an else. Because we won't know specifically how many there are there. So what do we want to do in that case? We just want to say multiple encryption offsets and then give them out comma separated. And then we just want to give out, we want to sort of dissect this tuple a little bit. So what I'm going to do here is do this in one step or a few steps, I guess, and then just explain it afterwards. So I want to convert, first of all, possible offsets to a string, and then I want to slice it so I can remove the bracket that would otherwise be here and here, you know. So if I want to just remove the first and last characters of a string, I can slice it with an offset which looks like this, or with a slice rather, looks like this. Start at the very first index and go up to, but not including the last index. So I can say string possible offsets and then slice that like this, and that would give me what I want there. Okay, so this is the automatic case done. Now I just need to sort of call that within my main method. Now just the else, which is what happens if they don't enter a valid. Cool. And I mean, let's see how we're going. I might have missed something there, but I guess the test will show me, right? Okay, so now my main is passing as well here. So that's actually kind of not what I was hoping to show, just because there was lots of things, lots of issues I guess students had where maybe a character was out of place inside their main method, and they were wondering how they'd actually go about fixing that. So let me break something. Let me try and do what a lot of students might have done instead. Put the new line here after the the welcome message, and then take it off out of the prompt here at the beginning. So you should be able to see now that main is not passing. And if we come down into what this actually is saying here, we can see this big assertion error message. On the left side here of the not equals to sign is what our program gave, and on the right side of the not equals sign is what it was expecting. And the place that you really want to look at, I guess, is sort of after this, 307 chars. It can be a different number here, but it essentially means that, welcome and all these characters were the same. It was just, afterwards that there's probably an error around here. So it's giving me what I'm assuming is the end of some encrypted text, end of some encrypted text rather, and then my code here has given them a single new line, whereas after the KHF here, they were expecting two. Another way of seeing this is that this is my sample, this is my program coming down here. It's done this, and then it was expecting me to have a new line here in between this first case and the second case, but that wasn't visible. So yeah, you really got to read these assertion errors quite precisely to find out that, there's just something as simple as a new line missing. Within the assignment, you could get quite used to it being just white space that was an issue. People tended to have everything else pretty sorted out rather. Maybe another example would be if I didn't have two spaces there. Okay, so in this case, it's a little bit easier to see down here what the error actually is. This minus sign is what I have, and you can imagine, you can remember that as like you take away this line, which is what you've written, and you add back what it's expecting here. And these two little spaces underneath means that there's two characters which I haven't given in here, right? And so it's clear that I just need to put two extra spaces in my prompt for the E case. So we can fix that like this. All right, but that's all good. In the next section, we'll move on to the extension tasks. So the next two sections of the assignment, the final two, are the extension tasks. And let's read the task sheet and see what we're actually meant to do for that. So the first extension task is that if 0 is entered as an input when a shift offset is requested, and note that that's only ever requested inside the main method here and here, we want to show that encrypted text or decrypted text for all possible offsets. So loop through from 1 to 25 inclusively and print out the encrypted or decrypted text for each one of those offsets. Okay, so to do this, I'm actually going to be creating a new function. So it's going to be called extension. So what is the extension going to take? It's going to take the text it wants to encrypt or decrypt, and it's also going to take a function. I don't know if you knew about this, but you can also pass functions into another function as a parameter, and we'll do that in this case. Docstring time. Okay, so very simply, what this function is going to do is it's just going to loop through all the possible offsets. I'm just going to print out. Now, this part where we want to actually pad the number on the left-hand side of I guess the print here, I'm going to use zfill for this, and it's going to work like this. I'm going to convert offset to a string first, and I'm going to call zfill on it, and I'm padding to 2 places. Okay, cool. And then the encrypted or decrypted text. So function, no matter what that is, and then we supply it text and offset. And that's our extension function done. So now we can use that inside our main like this. And a very similar sort of thing for decrypt. Something I'm thinking about right now is just to make my main a little bit more readable, I'm going to separate with white spaces the individual cases here. Yeah, that just makes it a lot easier for me to read at least. Yep, so let's just check that that first extension task is actually now working as we anticipated. And it's not, and why is it not? Sorry, let's just check that it's not first. Let's come down and read this error message here. You could either read the assertions or you could come down to this section and we can see that I am not giving it the 2 spaces it requires, very similar to that sort of situation we walked through inside the main function, inside our prompt actually as well. So that's a simple fix. Okay, cool, and the extension task is working. So just some quick housekeeping and then we'll move on to the extension task, or rather the second one. So I just showed probably at the very end of the last section that I did put some vertical white space here in between the individual sections inside the main method. A few other things I'm going to do is I'm going to put 2 spaces between each function. This is just a matter of personal preference, but at least for me it makes the sections a little bit more readable rather. The docstring for extension is not properly, this isn't as good as it could be here. So I want to say okay, I also added some vertical white spacing in some of the other functions just to break them up again. I think, for example, the handle automatic case was like this before, which is getting a little bit cluttered for my eye. I'd like to separate this up into the two logical sections here, this one where I'm actually, I guess, asking the user for input and getting all the variables I need, and then in this next section, based on those variables, I'm going to be doing specific things. And I think that was pretty much it. I will put in the spaces like I said I would rather. And then we'll just move on to the second extension task, I guess. All right, so the second extension task takes place within fine encryption offsets. We're going to be reworking this function a little bit to make it do exactly what we need it to. So if we come to the task sheet here, the second extension task is that we want to accept all characters, not just English letters and spaces. These characters should be ignored when encrypting or decrypting, and additionally we want to ignore all contractions, so words like we are or we are sorry or you've, we want to actually not check that they're English, and hyphenated words, we want to check the 2 individual words to see if they're both English. So let's write them down. We got a few things to do. Now these 3 comments here don't mean I actually have to do that sort of functionality in place here. They're just sort of for me to remember. But this first one, if the words are hyphenated, check both sides of the hyphens individually. Something we could do to complete this functionality quite simply is we could just say encrypted text dot replace, and we want to replace all instances of a hyphen with a space, and that will just make sure that when we come down and we split up the whole decrypted text, it's actually going to be checking both sides of the hyphens. And I mean, you don't have to then worry about what happens if we have 2 hyphens in a word just instead of 1. We don't have to worry about that sort of stuff. And actually, let me just check that replace will do what I think it will. Okay, but what is A? Okay, A is still high. So we have to say encrypted text is equal to encrypted text dot replace. Okay, so we've done the first section. We've done that first case. And actually maybe a comment there would actually be quite good. Ignore contractions. This is probably something that I want to do on an individual word by word basis, which means it should sort of take place after this step in here, after I first make words, which is a list containing all the words inside the decrypted text. Look, something I realize I can do though, is that down inside this for loop, right, and then I guess also inside this other for loop, I'm converting each word to its lowercase version, and I guess multiple times, and I only actually have to do that once at the very beginning of this whole function. It would save me a few steps, I guess, later on. So up the very top here, I can actually just say encrypted text. Actually, I could probably add this to the previous line lower, and that will by default, make every single character in the whole text lowercase. So I don't have to worry about converting it to lowercase later on, or each word to lowercase later on, rather. Okay, so ignoring contractions and cleaning up all other characters, how might we do this? So what I'm going to do is I'm actually going to write a function called clean. And clean will take a list of words and return only the words that should be checked if they're English or not. So where am I going to slot clean in? I'm going to do that down in this section down here, and it's just going to look like this. And that means I need to define the function clean. What does it take? It takes a list of words. So let's make a docstring. Okay, so how are we going to do this function? If I'm eventually going to be returning a cleaned list of words, well, let's start that off by making an empty list and building that up as we go along. So I want to go through every single word inside words, and then first of all I'll check if the word has any apostrophes in it. If it does, I'll just ignore it. I'll go to the next word. Otherwise, I'll see if it has any special characters to clean up, and I'll put that inside. I'll put that inside result. Let's write that out. First of all, what we wanted to check for is if an apostrophe exists within the word. So if the apostrophe is in the word, then I want to continue, right? Which means, look, I'll just go to the next word. I'm probably going to make a new function here, actually. Strip is already a function defined inside Python, so I want to make this something else. Strip special characters from a singular word. And there might be a function which does this already. I'm just going to sort of make my own here. Okay, so I mean, again, if I'm going to be returning a new word, let's start that off with being an empty string. Result is equal to the empty string, and then let's build that up as we go through the word. So for letter in word, this is almost similar to encrypt here. If letter dot is alpha, which means if it's an alphabetical letter, let's just add this to result. And then finally return result. Okay, now we can use this inside our clean function. So now I just want to say result.append the cleaned or the stripped word. So stripped special characters word. Is that all we need to do in this case? No, we also need to eventually return result here. Okay, and I think that's our extension task done. I might be missing something, so let's run the test cases and see what's up there. Okay, so looks like everything's working there. I'll come back with the actual tests we use to do the marking, and I'll just see how my code is going against them as well. Okay, so here are the actual marking tests, and let's just run them to see how well I do. So I'm passing everything apart from define and documentation, and I feel like that's because of an error with the actual files I have as opposed to something that we've done here. Just because, I mean, like, I've defined all the methods I'm meant to, and I know that, and I mean, documentation, I also have docstrings across all of these functions as well. So the last thing to do here, I guess I can exit out of a few of these things, is I'm just going to be scanning through this assignment one more time, top to bottom, and we'll just do a final cleanup of, you know, I guess style here. So I haven't put my name in here, but I mean, that doesn't really matter. You know what your name is. So this line, write your functions here, frequently will give you some comments like this that shouldn't be in your final submission. They're just sort of to guide you when you don't have anything else in this file. So we can delete that. Go through our encrypt function. That looks alright. Maybe separate these out into their individual cases just to make it a little bit easier to read, but it's not really a big issue. Convert them. What is them? Convert the letter is what I might say here. And let's see, does this go over the edge of the 80 character limit? Yes, it does. So let's see if we can either make this more concise or convert the letter to the corresponding encrypted character. Yeah. We don't really need that last bit. Okay. Going down, decrypt is fine, nothing to worry about there. Strip special character. No, that's all good. That's such a simple function, it doesn't really warrant a docstring. Also, maybe this could be done with a list comprehension, but I'm not the most familiar with that sort of thing, so I'm just going to ignore that. Okay, clean words. I noticed before that loop through all the words in words. It's not really that important of a comment there. It's very apparent from just what this line actually is. What I can comment here, however, is, you know, this is the section in which I am ignoring contractions, and this is the section in which I remove special characters. And yeah, that's I guess helpful for me just to see that I'm actually fulfilling what the docstrings are saying I am. So coming down, find encryption offsets. Not only are we breaking up the hyphenated words in this line anymore, we're also putting them to lowercase. Okay, and this is unnecessary white spacing here. I'm thinking at this stage that we could put in an inline comment for this section just because there's a few things going on in this line. Another thing that you could do to make this more simple is you could just, you could take off the clean from this, you know, and have words is equal to decrypt, blah, 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 dot split. And then in the next line, you would have something like words is equal to words clean. Oh, sorry, other way around, clean words. But I mean, I don't really want to put in the comment there. I think I could still make the argument that this is relatively readable. And I think that's all good. All right. So if there's anything I've missed, please let me know in the comments and I'll add it to the description of the video for other students. But apart from that, I mean, thank you very much for watching. I really hope this was helpful for you guys, even if I droned on a little bit there towards the end. Good luck for assignment 2.